Hi, it's math time with Mrs. Depperschmidt. We're going to do some more work with fractions today and talk about some problems that might occur in the real world. We have a problem involving roses in a vase that we'll work on first, and then we're going to talk about some window panes because it's easy to think about these as fractions. We're going to do some work with finding a fraction of the whole group of a set like we've talked about before. In the problem with the roses, the set is all the roses, and the situation is this. There are 9 roses in a vase. 6 of the roses are red, and the rest are yellow. To get started on this problem, I'm going to draw a bar model that represents all the roses. Each rose is one part of the set, or one fraction. Since there are 9 roses altogether, each rose is 1/9 of the set. And I drew the bar model like this. I've numbered the sections because my bar models are not precise. That's okay as long as they communicate the idea. And I've labeled the 6 roses are red. The rest are yellow. You can see that there are 9 sections, and I've also made a very heavy line in between the 3rd and 4th rows and between the 6th and 7th rows. That's going to help me think about the equivalent fractions in this example. Then I've drawn a number line that represents the same information. Each section on the number line is 1/9. I've labeled the 1/3, the 2/3, and the whole set of roses. We have 6 red, the rest are yellow. From this model, it's easy to deduce just by looking that 1/3 of the roses are yellow, and that's the answer in simplest form. We could say 3/9 because that's really right. It's 3 individual roses out of the set of 9. 3/9 is the equivalent of 1/3. That's the problem about the roses. Next, we'll talk about window panes. Sometimes windows are made with several different pieces of glass to make up one whole window, and each little individual part is called a pane. Those are the fractions of the entire window. We're going to talk about one window that is made up of 12 window panes. There were some children playing, and the ball accidentally broke 4 of the panes of windows, and I've shown those on this bar model with some little squiggles in them of broken. The situation we'd like to figure out is how many window panes are intact or not broken. Once again, I've drawn my bar model with 12 pieces because the window has 12 panes. Each pane is 1/12 of the whole window. I've indicated the equivalent fractions like a number line just above the bar model. There's 1/3, 2/3, and 3/3 marked off for reference points. I've also shown the fractions below. Out of the broken windows, there are 4/12. Intact, we can just see that by counting. 8/12 are intact. Now, in order to find out how many are intact in its simplest form, we'll use that division trick where we do the same thing to the numerator as we do with the denominator. That's one of our main, very important rules about dealing with fractions. And I know that 8 and 12 are both evenly divisible by 4, which gives us our simplest form. When I look at 2/3, I know that I cannot divide further, so that is as simple as it can get, showing that 2/3 of the window panes are not broken. Those are just 2 examples of situations where fractions work well to explain a situation, and you'll encounter more and more of those through your life. I know that fractions are getting easier each time we work with them, and they're just quite exciting once you feel comfortable. The more practice you get, the better it will be. I'm glad you're sticking through this. Have a great day, and remember, be kind.